All right. And good morning. Welcome back to QR, this wonderful, beautiful, haha, irony, rainy, dark, cold morning. Well, that's not cold. Anyways, back to the point, some friendly reminders. Our homework for 5.2 is due today. 5.3 is due next class. 6.1 we'll finish today, so that'll be due on the 27th. 6.2, probably not going to finish till next class. We'll have that due on the 29th. Your Excel population is due on the 27th. So that's a week from today. We're going to have one, maybe two more Excel homeworks, so there's not too many left of those, thankfully. And I'm just about caught up with all of my work from not being able to do anything for half of last week. So I'm going to start grading y'all's projects the second I stop teaching today. And as soon as I have those graded, you'll see your grades in Canvas in the grade section, like where you can see your quizzes. Also, your discussion board participation grades are in there as well. Anything else I need to say? Yeah, but specifically, as long as nothing crazy happens, I will have all your projects graded by 3 p.m. tomorrow. I'm going to do my best to get them done today. I don't want to make a promise I can't keep. I really, really believe I can have them done today, but I will definitely have them done no later than 3 p.m. tomorrow. I'm sorry it's taking me that long to get them, but it is a lot more to grade than usual. And again, had a weird issue. So, where am I going? Here we are. So in 6.1, we had all this jazz. Last time we talked about constant percent change. And we used a growth factor. So constant percent change is when you see the same growth factor over and over and over. If you're growing 3% every year, if you're growing 10% every year, as long as that number doesn't change, we saw patterns. We developed a formula so that we didn't have to do this iterative or recursive process. Those words mean the same thing. I know I only used iterative last time. So we said, and again, super, super, super important. When something is changing the same amount every time, and not the same amount, the same percent amount every time, the new is the old times the growth factor or decay factor. It's a minus if it's a decay factor. We had that note over here. How do you find the new? How do you find the next one? You take the previous one and you multiply it by the growth factor. What's the growth factor? It's 1 plus or minus if decay, and then the rate of change, the percent change. So if you have a 3% growth, it's 1 plus 0.03. If you have 3% decay, it's 1 minus 0.03. So we spent some time and we developed a formula for this. We said, okay, you just end up multiplying that growth factor over and over and over and over and over, multiplying the same thing over and over and over, turns into an exponent, where the exponent is the number of times you multiply it. So if you just want to find some random year further down the line without finding all the middlemen or women, you just take the new. The new is, you take the original, the oldest, multiply it by the growth factor with an exponent of however many years are going by. But we said this only works if we're compounding once per year. This formula that we developed, this A equals P times R, 1 plus R raised to the T, only works for compounding once per year. That's not the only way things compound. We will get into that maybe today. I actually want to take a sidestep and do some Excel problems for the most part for the beginning today, and then come back to this stuff. Now, I may have said that you have to memorize this formula. Where is it? But if you look carefully at this formula sheet that I don't think I have it in Canvas yet. I might have it in Canvas under your test section. I don't remember. Either way, this will be going in Canvas. And you will want this formula sheet for your final exam. It is very necessary. So I mentioned, oh, you had to memorize this. Well, it's actually a lie. It's the first formula I put on your formula sheet, if I said that last time. I used to make my Math 152 students memorize it. But in here, quantitative reasoning, you got access to this on your own. So I just say, here's a formula sheet with pretty much everything. So this is kind of our starting point for these compound interest formulas, for these constant percent change formulas. But they're going to get worse. And they're going to get a little uglier. And then there's going to be something different. And then they're going to get worse. And then they're going to get worse. And then they're going to get worse. And then they're going to get really worse. So we are going to, we will not show the derivation of any more of these formulas, arguably one more. You definitely will not see the derivation of any of this stuff. So again, this will be a formula sheet you're allowed to use, and the point of these exercises is, do you know which formula to use? So it's not memorize this big kooky crazy formula. Now, if you go into advanced mathematics classes, they will make you memorize them sometimes, depending on the teacher, depending on the point of the course. But this will be a formula sheet you can have for your final exam. And that compound interest annually, meaning you gain money once per year, that's the formula we've seen. That's the only one we've seen so far. Back to notes. So again, what do those letters represent? A represents the future value, what we've been calling the new. P represents the original. Now, you can't say it's the amount at year 3. When we're in year 4, we're calling that year 3 the old. We're not thinking about that. When we're using this formula, the old is the old, the original, the oldest, the OG, if you will. Your R is your annual interest rate, or APR, annual percent rate. And we're not always given an APR in the real world. Sometimes we're given an APY, but they're generally pretty close to each other. We also aren't always talking about this type of formula. Sometimes we'll talk about continuous change, which is in the second section. It makes things a little wackier, and the only reason we even do that is because of Excel in this course. It's kind of annoying. I honestly don't think we should cover it at all, but because of the way Excel displays these exponential equations, we have to cover it. And then T, of course, is time, generally in years. So what if you were to compound on a shorter timeline, like months or quarters or days? What change does the R go through? What change does the T go through? Hint, remember periodic rates? So we said a periodic rate, if we wanted a monthly rate, that was the annual rate, the APR, and we had to divide it by 12 because there's 12 months in a year. If we wanted a daily rate, we'd divide it by 365, or 360 if we're using the banker's rule. If we wanted a quarterly rate, we divide by 4 because there's 4 quarters in a year. So that was periodic rate. Well, this is literally the change that happens to the R. A monthly rate just takes the annual rate and divides it by 12. So if you compound monthly, you take the annual rate and divide it by 12, because that's going to give you the rate for one of the 12 months. So in particular, let's say you had a 24% APR, like a credit card. That means your monthly rate, to get that, you divide it by 2, and it would be 2%. And some credit card companies love to, on their little bill, say the monthly rate, oh yeah, it's just 2% this month. Oh, that's not too bad. That's 2% a month over 12 months. That's 24% for a year. That sucks. That's terrible. Hold on a second. So when we compound on a shorter timeline, we have to change our rates just like a periodic rate changes. So this R right here changes to R over, and let's just say N, where N is the number of times compounded. So the 12 or the 4, or the 360 or 365. Okay, well, what about the T? What's the T go through? So this exponent is supposed to be the number of times that you compound. The exponent is not necessarily the number of years. The exponent is the number of times you compound. So let's say you compound 12 times in a year. You compound monthly. Well, that means over 1 year, you would compound, don't overthink it, 12 times. So that exponent would be 12 if you compound 12 times in a year. If you want to go 2 years in, the exponent would be a 24. If you go 5 years in, the exponent would be a 60, because there's 60 months in 5 years. So what happens to the number of payments, interest payments, whether it's you're getting them or someone else is getting them, is you have to multiply by that same n. The number of payments becomes nt. So that's what the exponent becomes. This exponent changes to n times t, the number of times it compounds. The same idea as the total number of payments when you're making more than one payment in a year. 2 years, 24 payments. 5 years, 60 payments. N times t, 12 times 2 or 5 or whatever the number is. So those are the two changes that happen to this formula if you compound more than once a year. So again, your R turns into R over N, and your T turns into NT. So that formula becomes this. Now again, I'll write the old formula. The compound annually was A equals P parentheses 1 plus R raised to the T. Versus this is compounding N times per year. A equals P parentheses, that's still there. 1 plus, that's still there, but the R turns into an R over N, and the T, the exponent, turns into NT. So again, the thing that's adding the R is the periodic rate. The exponent is the number of times it compounds. So periodic rate becomes R over N, the compounding times becomes NT. You do not have to memorize that if you pull up that formula sheet. Again, that'll be in Canvas soon if it's not already. It's the second one here. It's a little bigger, it's a little beefier. You have to be careful with your order of operations if you're going through and doing the inside and then hitting enter and then the exponent and then hitting enter and then multiplying by the P. But if you've got a scientific or graphing calculator, most of, if not all of them, are capable of handling this as a type all at once situation. Now I have a note that is all capitalized and in giant letters. Always pre-multiply the NT in your exponents. When you go to punch this in a calculator, this is what I mean. Always, before you just type this all at once, whatever that N times T is, if it's 12 times 5, which is 60, don't write 12 times 5 in the formula in your calculator. Write it as 60. You are highly likely, and I would say 95% likely to make a mistake if you don't do this. And the reason I say 95% is because some calculators are able to handle a non-pre-multiplied exponent because they're more fancy. My TI-83 can't unless I wrap it in an extra parentheses. We will see this done correctly and incorrectly when we get to some examples with it, I promise. But I wanted to go ahead and get those two formulas out of the way. We'll apply them later. But for now, let's not use any of these big kooky crazy formulas for now. Let's just have Excel do our work, because I imagine 5 years after this course, you're not going to remember these formulas. You might have a hard time digging them up if you haven't already set the formula sheet on fire, so to speak. But Excel is still just using an iterative process. This quantitative reasoning course is meant to teach you some very basic ideas that you can use, you will hopefully remember 5 years from now, because it's not the quadratic formula, it's add and multiply. Okay, that's it. Just keep doing it. But if you don't learn Excel, if you're one of my 4 or 5 students not doing your Excel homework, shame on you, then the whole point of this course is out the window. So in Excel, we can see each and every iteration of interest and future value calculations. This formula, these formulas, the two with the parentheses and the exponents, are better when we just want one specific value in time. So let's do some Excel stuff. And we're going to do several problems. So example 1 is the first yellow, example 2 is the green, example 3 is the yellow, and then example 4, if you want to call it, can be the non-highlighted section down here. But I don't want to show too much at once. Boom, there we go. So we're going to make several financial plans for our buddy Bob. So Bob, the yellow one, call this example 1 for the day. Bob wants to deposit 10 grand into a CD, which is a savings account where your interest rate is fixed for a period of time, called a certificate of deposit. And he's going to do this for some number of years. So he's got this CD that's locked in no matter how long he leaves his money in. Quite honestly, this doesn't exist, but let's assume it does. CDs usually don't have rates locked in any longer than 5, maybe 10 years on extreme cases. And honestly, you would never want a CD of 2% locked in for 40 years, but again, not the point of the problem. So Bob's going to take 10 grand. Maybe this was a graduation present. He's got a rich family, a rich uncle, something like that. Maybe this was a grandma passed away, and this was his right. And instead of Bob just going and spending 10 grand on nothing, he puts it away for a rainy day. So we're going to see how much money Bob's got in there 1 year later, 5 years later, 10 years later, and 40 years later. And we're going to record these values and their interests, record these values, interest and total. So how much money he got for free, I'd call that the interest, and then make a scatter chart of this and see what happens. Now I use the term free money here, and you might say, well, if Bob got this from his grandma, then the whole thing's free. What I'm saying is I'm calling interest the free money. The principal, his deposit, is not free because he could have done something else with it. So, Excel. We are starting with, let me just make some notes somewhere over here. We're starting with 10K. Our interest rate annually, ARP, we're not retiring, not yet at least, was 2%. And the times we're doing 1, 5, 10, and 40, I believe, in years, right? Let me confirm that. 1, 5, 10, and 40. Record these values, interest and total, make a scatter chart. So let's have a column for years. It'll start at 1 and go to 40 ultimately. Then let's have a column for the beginning balance. Then let's have a column for the interest. And let's have a column for the ending balance. I'm going to widen my column so that everything looks nice and neat. How much are we starting out with? Well, that's $10,000. Boom. How much interest are we earning? We're earning 2% per year. Now, I'm not typing 2%. That's not, this is wrong. This is wrong, this is wrong, this is wrong. Interest rate is 2%. How many times have I said your words are critical? Because if we're in class, and I'm only speaking historically, I'm not speaking for you. Historically, half of my students always just type 2% there and move on. No. Interest, when we're looking at a small scale, when we're looking at simple interest, is the product of how much we have and the interest rate. So how much money do we have? We have $10,000. So that's this cell. And we're going to multiply it by what's the interest rate? 2%. Now, I don't want to just type 2% here. I want to have that listed somewhere. So over here to the side, let's say APR, and let's have 2%. That way I can use a cell reference and remind you how to use these for the 4 or 5 of you who refuse to do anything. Shame, shame, shame. Haha, okay. I'm kind of curious if y'all hear that motorcycle going down my road. All right, so interest. All right, so that's 10,000. I don't know why I have a percent there, times 2%, right? No. What's wrong with that? I didn't do an equals. Also, I typed 2% instead of using a cell reference. Equals. And I don't want to type 10,000. I want to use the cell reference. Times. Now this 2% over here, I need to fix that because I don't want this 2% moving. Remember, as you fill in formulas, as you drag them down, they're going to change your cell references unless you say not to. So I'm going to double cache this one. Oops. Need to do it here. Cache, cache. I don't think that thing needs to move at all. So 2% of $10,000 is 200. Why is that displaying as a percentage? Dollar. There we go. I have something covering that, so I couldn't even see it. So again, I don't have that $200 permanently fixed. It's a formula. If I double click, I can see the formula. I can also see it up here. The ending balance is the sum of what you had and what you get for free. So equals, equals. And I don't have to use the sum function. If it's just two things, click this cell, add, click this cell. Hit enter. It should be 10,000 plus 200 is 10,200. And it sure enough is. So that's how much we have after year 1. So how much do we have after year 1? We have $10,200. How much interest do we have? $200. So you should be recording those. I asked you record years 1, 5, 10, and 40. The interest was $200. The total interest is $200. Ending balance is $10,200. So year 2, year 3. Oh man, I gotta do through year 40. This is gonna get tedious, right? Nah, let's not do it that way. If I have this cell highlighted, if I grab the fill handle and I drag it down, let's just go to year 10 for now. Let's see what happens. Year 10 would be here. Oh, year 11111. That's not right. Undo. So if I grab the fill handle, I mentioned, and it was a long time ago, so most of you probably forgot, control tends to change filling functions. If I hold control and drag this down, that will actually increment the numbers. Another way you can do this is, if I have 2 typed here, if I highlight both of these and then fill it down, Excel goes, oh, it looks like you want me to add 1 each time, and it does. So there's several ways to do that. All right, so our beginning balance in year 2 is supposed to be the ending balance from year 1. I don't want to just type 10,200 because again, after this, I just want to fill everything down. I don't want to have to do any more work after year 2's row. This is where we link the cell. We go equals the ending balance from previously. So now they're linked. For some reason, it's not displaying. What is happening? Let's make sure that's a, oh Lord. Sometimes Excel is silly. Maybe if I make this wider. So equals ending balance. There we go. Just needed to be a little wider. Probably because of the cents. And I've mentioned that in class. If you end up seeing those hashtags, those number signs, it's usually scrolling in or out or making a cell wider will alleviate that. The interest formula is the same. I've used a fixed cell for this 2% over here, so I should just be able to drag that down once. And it does, it makes sense. A little more balance gives us a little more interest. The ending balance was adding B2 and C2. If I drag that down to fill, remember grab the fill handle, a little more money. Now what I can do is just highlight the entire row, beginning, interest, and balance. I already have the year column set up, so I don't need to highlight that. Now grab the fill handle, and I can grab this all the way down to 5 years. And we can see 5 years in, we now have $11,040.81, giving us a total interest. I'll write this one. Balance is the 11,040.81 in dollars. Oops, come on. In dollars, that was the balance, and the interest was not $216.49, it's the sum of all the interests, or you could just take the final ending balance and subtract your initial deposit of 10,000. If you do 11,040.81 minus 10,000, you will get 1,040.81. Again, 2 ways to get that. It's the sum of these 5 interests, or you can do the ending balance minus the very beginning balance. That's the total interest. To be specific. Next, we're supposed to go to year 10. Well, instead of typing, highlighting, grabbing a whole bunch of things, I can highlight this whole cell, these whole 3 cells, grab the fill handle, drag it down to year 10. Now we can see 10 years in. Let me just make these columns. Balance, total interest. There we go. So 10 years in, I skipped writing it for 1 year. It was 10,200 and 200 respectively. Our total balance is now at 10 years, 12,189.94. And our interest, if you subtract 10,000 from that, you will get $2,189.94. To go to year 40, let's see if I can highlight the year. If I take that down 1, does it change? It does. When you're highlighting a whole bunch of stuff, it tends to know that number is going to go up. But when you only highlight the 10, Excel doesn't quite know what you want, and it just says 10 again. You'd have to hold the control down. So let's highlight all these. And I got to go to year 40. Now year 10 is on row 11, which means year 40 would be on row, think for a second, 41. Okay, year 40. Ending balance of $22,080.40. Again, that was $22,080.40. Meaning the interest, if you subtract, where did I type this, I thought? 2,100. I must have hit undo too many times or something. And then this is going to be $12,080.40. So that was 40 years in. Now I ask you, what was the point of this problem? The point of this problem was to see the compounding effect over time. The first year, you get $200 in interest. The second year, 204, it grows a little. Then it grows a little. This free money is growing each year because the free money you get is based on the balance, and the balance is growing each year. This is called a snowball effect. You're getting money on money on money. That is known as compounding. So now, when you are 40 years in, and actually it's about 36 years in, roughly, where the amount of interest you're getting is twice as much as you were getting at first because your balance is about twice as much as it was at first. And if you did this for another 40 years, which most people aren't going to live long enough to be able to do that, but way too far. Holy cow. Let's go to row 81. So if you somehow managed to put this money away for 80 years, now you've got almost $50,000 when you started at 10. It's a snowball effect. Your money grows faster and faster. The more money you have, the more quickly your money grows. Do yourselves a favor and try to recreate this, as well as the next ones I'm going to do. So the next thing I said was to make a scatter chart for this. A scatter chart of, specifically, the year and the ending balance. We don't want to look at the interest. You could. We don't want to look at the beginning. We want to just compare the year and the ending balance. Where is that? Make a graph, a scatter chart. And I thought I said somewhere to do it. Yes, use the years and ending amount. I also mentioned, because they're in separate columns, as a reminder, that control button is wonderful. You use control to highlight separate regions. So we like to highlight our labels as well. So I'm going to hold year, go all the way down to 40. Then scroll back up. I'm going to hold control, hit ending balance, and scroll down all the way to the 40th ending balance. Let go of control. So I've got those two things highlighted. We go to insert. We go to the scatter chart, the little dots. We do the simplest one. And we can see that we have a diagram of our ending balance. We have our years on the horizontal axis. We have the dollar amounts on the vertical axis. And it kind of looks like a line. It kind of looks like a line. Will it let me draw? Yes, it does. Okay. So if I just said, oh, wow. Oh, it's just pulling me up. Okay. So if let's do an anchored approach. Let's connect the first and the last one. And it would look something, this is going to be awful, trust me. But that line, if I connect the first and the last, if I do that anchored approach like we tried, it doesn't hit any of those other points, but it's ridiculously close to it. So that's an anchored approach. Let me undo it. If I let Excel do a line of best fit, though, we can go back to insert. I want to make sure I'm on this. We're on design, add chart element, add a trend line. Remember, this is relevant for a homework you have due soon, an Excel homework. Linear, and you can see the dots. They're a little off down here. They're pretty good in the center, and then they're a little off here. There's our line of best fit. And again, that's using a process that we don't want to learn. We don't want to learn the sum of least squares process for finding that. Just let Excel do it. But it's not bad. So there's the line of best fit. It's good, but it's not perfect. Check out if I'd done this instead. So let me undo that. Add chart element, add trend line, add. I've already spoiled that these are known as exponential functions. A constant percent change is known as exponential. Look at this. You can't even hardly see the dots that were added because they are fitting this thing perfectly, because this is exponential, because it starts bending. At some point, this thing is going to pick up speed and start growing through the roof. But with a 2% interest rate, it's not going to explode anytime soon. 40 years, still don't even see that explosion. So let's go back to the instructions. Now let's say Well, before we do the green example, let's say instead of Bob putting this money in a 2% CD, which is an extremely safe way of investing, let's say that Bob earned his money aggressively with mutual funds. And let's say that Bob earned the historical average of 7% a year. Now, that doesn't mean Bob gained 7% a year. It means on average, he gained 7% a year. So let's hold on to this graph. And remember, when I put the interest calculation, I didn't just type 2% in there. I used a cell reference over here. It's using this 2% every time. So now let's make that 2% a 7%. So Bob goes from safe investing to what most people should be doing over their life, more risky investing. Let's make it a 7%. Now, when I hit enter, all of these numbers are going to change. The interest is going to change drastically. The ending balance is going to change drastically. Now, you might not see that drastic change at year 1, 10,200, but we will see it at year 40, the 22,000. Drum roll, enter. I'm going to make my interest column a little wider so you can see everything. Look at that. We now gained $700 the first year instead of 200, so now we're at 10,700. By year 5, we're now at $14,000, which was 11,000 originally. So now we have 4,000 in interest for free versus only 1,000. So that's 4 times as much money already just 5 years in. At year 10, we're almost at $20,000 before we were at 12. That's 5 times as much free interest as we've gained, 10,000 versus 2,000. And holy cow, look at year 40. $149,744. That's 150 grand. I hope everyone who's watching just had their mind explode a little, because this is why we are supposed to do risky investing. Because risky investing means you get a higher APR, and the difference of a 2% versus a 7% APR, instead of us having 40 years later 22 grand, which is nice. We started with 10. 22 is not terrible. It's better than what most Americans do and just throw it in the trash can. So it's great having 22 grand from just putting 10,000 away for 40 years. But if you can put 10 grand away for 40 years, boom, $150,000. That's a solid portion of retirement. It's not retirement. It's a good start though. Look at our curve now. See that curve updated. If I hit undo, so that I might have to hit undo a couple times. So now there's my rate of 2%. Look how flat that curve is. Remember how we're talking about flattening a curve with this coronavirus? We're trying to lower the percent change every day. This is flattening the curve. And we're talking about our investments. We don't want a flat curve. We want a round curve. We want this thing to explode. So switching from 2% to 7%. Watch that curve. There it goes. I don't know why I had to hit that 3 times. Look at that. This is about where I'd say we start hitting the explosion and we just steamroll, we snowball, and this thing then ends up destroying a village, this big snowball of money, right? Not actually destroying a village, it's a nice snowball. It pads our wallets. So that 40 years in, we get $150,000. Maybe you make really good investments. Maybe you, instead of just going with the S&P 500 for your investments, maybe you are a little more aggressive and you end up seeing some positive results of your more aggressiveness. Maybe you get 10%. So let's change this 7 to a 10. Let me widen my interest column first. I think that's why I had to do a couple of the changes. So let's make this a 10. So we had $150,000 previously. Now we have $450,000 because we made some slightly riskier but good investments. Now look at this curve of our money. It's exploded even more. Again, $450,000 just by putting 10 grand away for 40 years. This is not how you retire though. This is not how you retire. You don't retire by taking one lump sum of money and putting it away and never adding to it. You should be adding to it every month or every week or every day or at least every year. But this is a good start. So that interest rate that you get, 2% versus 10%. Oh man, I'm 5 times as much money, right? So instead of gaining $12,000 for free, we'll gain like $60,000. Yeah, that's fine, right? No, you don't gain $60,000. You gain $440,000. And in the last example, it was $140,000. You get so much free money when time is on your side. If you are 18, start putting away money now, because time is how you get this explosion of your dollars. Every 10 years you wait, you more than have to double your investments in order to see the same results. All right, so now let's finally get to the next example, the green one. So Bob has $30,000 that he receives from his grandma. So 10,000 last time, 30,000 this time. And he's going to put this into a mutual fund earning 8% interest. So a little better than the average S&P, a little worse than maybe a more aggressive investor. So he's going to deposit this money and he's going to wait 35 years. How much will he have? How much was free money? By that I mean interest. Make a scatter chart as well. So Bob got a much nicer parting gift from his grandma of $30,000, or maybe she just gave him $30,000 because Granny's got Benjamins, whatever. Whatever the scenario has to be to believe it. I certainly don't have any believable scenarios in my life where someone's giving me 30 grand, because that's not where I come from. But again, that's my story, not Bob's or yours. I'm sure that most of you share my story, though, because that's the average American. Anyway, it's not the point. So why is he putting his money away for 35 years? Well, most people, at least right now, are retiring at about age 65, maybe 70 by the time we're ready to retire. Those of you who are my age, or or younger. So let's see. If we're retiring at 65, if you subtract, that makes us 30. So Bob's, probably losing his grandma around the age of 30. And then, like I said, instead of Bob just going out and buying some fancy new Jeep, like you do, like you shouldn't necessarily do. And again, not telling you what to do, but another option is you take that money and you make a nest egg out of it. And Bob's just saying, we're putting all this in the market. We're putting this in the stock market. I'm buying tech funds. I'm buying medical funds, maybe a little bit of stock here and there, whatever. And after those 35 years, it turns out that his average rate of interest, some years good, some years bad, some really good, some terrible, he ended up with an 8% average. Again, pretty typical over long term. How much is he going to have? So let's go back to that previous spreadsheet we had. Let's clear out all our numbers except for the years. We can leave the years. Well, there we go. I don't know why it left the zeros there. That's very odd. There we go. And we don't need years through up to 40, just 35. So our beginning balance is no longer 10,000, it's 30,000. I'm just going to delete this stuff. Hopefully you can remember that we're doing 30,000 at 8% for 35 years. So the interest, that's the beginning balance. If I double click, remember, you can see where the cell references are. So the beginning balance times our interest rate, but it's not 10%. It's supposed to be 8%. So let me adjust that. So that means in the first year, we're getting $2,400 for free. Our ending balance, that was the sum of them, the B2 plus the C2. And that's 32,400. Year 2 starting balance is supposed to be year 1's ending balance. So we need to link them. So I go equals, and I click this cell, enter. Then I can click the interest cell and drag it down 1, fill it. Then I can click the ending balance cell and drag it down 1 and fill it. If you don't trust these, you can double click them. Oh, the ending balance is adding the blue and the red. That's good. The interest is multiplying the blue and the red. That's good. Remember, without that fixed cell reference, we would now be below the 8%, and it would not be right. Now that I have the cells linked, year 2, I can just drag down all the way to year 35. Let's take a pause at year 10, though. Let's see, along the way. Year 10, we started at 30. Now we're at 64. We've more than doubled our investment. Let's go to year 20. $139,000. So 4 times our investment would be about 120. 5 would be 150. So this is about 4.5 roughly times our initial investment. Go down to year 30, drum roll. Sorry, 35. We're going to 35. We started at 30. We're retiring at 65. And look at that. A very similar number to what we had with the other problem. So that last problem, when I changed the interest rate to 10%, I believe, we started with 10,000, and after 40 years, we got almost a $500,000. In this problem, we started with 30,000 with an interest rate of 8%. Over 35 years, we get about a $500,000. I'm just trying to get you to see how the different interest rates, the different amounts of time, can have a cause and effect on this. So now if we plot this, if we plot the year and the ending balance, so let's highlight all the years. We're gonna let go of the mouse. We hit Control. I should probably scroll up first before hitting Control. So I'm not holding anything. Let me scroll up. Now let me hit Control, grab the ending balance, highlight down to 35. There we go, year 35's balance. Then we insert our scatter chart, and we get that similar looking curve when we were seeing the explosion with the higher interest rates last time. With that 2% interest rate, we didn't see the explosion. You would if you go maybe into hundreds of years, 200, 300, 400 years, you'll see an explosion. But that interest rate, it doesn't take a very large interest rate to see an explosion sooner than later. In terms of a lifetime of investments, 6%, 5%, that's about where you're able to see some explosion. Anything less than that, it's more like linear growth, which you don't want with your money. So if I insert a linear trend line, it's not really that great, right? It's not a great predictor. It's not very accurate. It's accurate here and here, but the rest is kind of trashy. So if I undo that, if I add the exponential one, again, you can almost just barely see it. We're getting a little more space here, so you can see those extra dots here. This thing fits absolutely perfect because this is known as an exponential function, because it is a constant percent change year on year. Now again, is this something that most of us are going to be able to do? Probably not. Maybe 1% of you. I'd say out of my friends, most of them, definitely not in this situation, but I do know someone who just lost a parent and they got a very sizable sum of money and immediately came to me because they know I know all about this stuff. Hey, what should I do? What should I do? Do I put this towards a down payment on a house? Do I go have fun with it? Do I put it away for investing? And I said, well, considering the size of your money, take a little for each. Take this chunk and put it towards investing. Take 5 or 10% and have fun with it, but don't spend the whole thing on fun. Again, unless that's just your lifestyle, in which case I'm not telling you what to do. I'm just giving sound financial recommendations, not advice, things that you could do. Because this is not a financial advising class. Please do not take this as financial advice. Please do not sue me. Education purposes only. Make your own decisions. All right, so next example, we're going to make it a little more interesting. Bob is 18 and wants to retire at 68. So like I said, 67, I think, is retirement age right now. That's when you can start getting full Social Security. That's likely to increase over time. You can get Social Security at 62, but with reduced payments. You can even collect on your IRAs at 59 and a half. Your individual retirement accounts. Those are outside of work. So Bob is 18 and wants to retire at 68. I didn't tell you what the time is. You have to deduct that. So 18, 68, guess what? That's 50 years exactly. Let's assume it's from day one. It's birthday at 18, birthday to 68. No weirdness. So 50 years of time here. That's a long time to be able to shovel money away. And you're not going to be able to shovel a lot of money away at 18. But once you get that degree and you start earning that bread, maybe you can put away a couple $100 a month. Once you get your house paid off when you're in your late 50s, early 60s, you can start putting away, maybe $1,000 a month if you really wanted to. If you don't refinance your home into the ground, that is. This is the problem I was alluding to at the beginning of the semester. This is my favorite problem of the entire semester. This is going to show you what you can do. We've made our budgets. We might have realized that we're spending a little too much on, say, fast food. So I pick on Starbucks individually, but maybe this is your Chick-fil-A chicken sandwich every day that you eat, or just something. You eat fast food every day, and it ends up costing you $5 or $10. Instead of spending that $5 or $10, you make food at home, and it costs you $2 or $3. You take that savings, you put it away into a retirement account or something else. something less, quote, wasteful. So this $3.50 every day, we're going to deposit annually. We're going to do this once at the very end of the year. So we're going to deposit his annual savings. $3.50 is not what Bob saves over a year. So this is another case of if you were in front of me in class working on this, a third of you historically would put, oh, Bob deposited $3.50 for the year. No, he didn't. He deposited $3.50 a whole bunch of times. So that's some trig stuff. Don't worry about that. How many times did he deposit $3.50? Well, there's 365 days a year. So times 365. Now, is this problem that relevant right now? If you're not going to Starbucks every day, you can still do curbside probably. I don't know. I don't get Starbucks. Some places are doing that, some aren't. But not the point of the problem once again. This is normal life. So that's $1,277.50 every year that Bob's spending on coffee. So here's your alternative there. Bob can just go to the grocery store, buy a bag of coffee beans, grind them up. If you don't want to grind them up, get the pre-ground stuff, make coffee at home. That's like 20 cents every day. That's $1,277.50 that Bob can deposit every day. This is not going to be the same problem. Don't worry about that stuff. But let me just go ahead and have this set up. So our starting balance, and I need a year column as well. I need to move these. Remember, to move things, you can highlight the cells, grab the border, drag them over. So year. So year one, we have a starting, and this does not need to be a dollar. I got to move some stuff on my screen. We don't want that accounting. We just want that as a general. There we go. So a starting balance. How much does Bob have at the beginning of year one? Bob has nothing. How much money is Bob adding over that year? Well, we calculated that $30.50 over 365 days. He's adding $1277.50 at the end of every year. So $1277.50. So before he earns interest, that's how much money he has. This is the sum of what you start with and what you add. Before you get your interest, you need to add the money that you had previously and what you added to the pile. Now, we didn't have anything originally, so it seems a little weird, but we are supposed to add, so equals, add what you had previously, the starting amount at the end of the year, plus how much you actually add, the amount you didn't spend in Starbucks. So we added $1277.50. Now, the interest that you gain over a year is going to be the interest that you had. So it's going to be based on the starting amount. If you put this money in on the 365th day, you are not going to get interest on this money. So as a special note here, the interest is on the starting balance of the year. So the interest is equal to. Now, what did I say his interest rate was going to be on average? He's going to get 9%. So he's going aggressive. And he's doing a little bit of his own picking and choosing, which tends to make people make a little more money as long as you actually learn how to do that. If you don't, stick with the S&P 500, stick with a little bit of bonds, stick with a little bit of international. The standard 3-fund portfolio is what a lot of people would say to do, which again is not my recommendation. Research and make your decisions. So Bob, starting at 18, super aggressive, ends up with 9% return over his life of the loan, which will be 50 years. So 9%, 9%, 9%. So let me just make a little memo over here. Oops. So it's 9% return for 50 years with a $1277.50 deposit each year. So his interest is the product of his starting balance times his interest rate of 9%, which I have over here. I must have hit something. equals the starting balance times the 9%, which is cell I2. Now we're not going to want that moving. We need to fix it. So I need to go back to it and put in the double cash. Cash, cash. So the interest is nothing because we didn't have any money in the account the first year pretty much. Our ending balance is going to be the sum of what you had before the interest and the interest. So equals. It's the sum of the pre-interest. So that right there is what you started with plus what you added. And then plus however much we get in interest. So our ending balance is a mere 12,7750. We didn't get any free money because the first year we added that money on the very last day. So year 2, our starting balance of year 2 is the ending balance from year 1. So we need to link these two cells to each other. So we go equals the ending balance. So again, that first year, because we put all of our Starbucks money the last day of the year, because that was when we accrued our last $3.50. So we say, all right, let's slap it in all at once. Should you do that in the real world? No, I'd say add it each day, but it complicates this Excel spreadsheet. It complicates it a lot, makes it massive. So now the money that we add, this is going to be the same as previously. I can actually, I believe, just drag this down and it won't change. Yes. So this 12,750 is what we put in from the first year. This 12,750 is what we're putting in for the second year, meaning the pre-interest balance is just the sum of what we had and what we added. But I have a formula already built in, that blue plus that red. If I drag it down, it should be fine. And it is. 1277 plus 1277 is 2555. Then our interest, remember the interest is based on before you added. It's the pre-interest, I'm sorry, it's the starting balances amount times the APR. So our interest is equal what we had all year long times the interest rate. I don't need to be doing that. Remember, we had a formula. We can just drag it down. So again, this was what we started with times what we have all year long. I could have typed it again, but I'd rather just drag it down. So this year we get 115 bucks for free. If I double click it, the starting for balance for the year times the APR. So 115 bucks for free. Not bad. You know, not amazing, but not bad. Now I can drag the ending balance down. Drag, what I did was move. Make sure you grab the fill handle. Remember that undo button is wonderful. So now, 2 years in, we now have almost 3,000 bucks just by giving up Starbucks, by having our coffee at home, or instead of going fast food every day, making food at home every day. You can still splurge every now and then. All right, so year 3. Let's take this to year 10 and see what we have. Oh, that didn't work, did it? Because I didn't have both of these highlighted. So let's go to year 10. Now I can highlight this entire row, and I should be able to drag this down. So year 3, we have 2,700 roughly, because that's how much we ended with in year 2. So we start with about 2,700. We add our, now this is a problem. Look at this. It thinks I'm adding 1 each year because of the way I did that. So I need to go back and delete these. And I'm doing this intentionally, believe it or not, because you'd probably have the same issues. So if I just have that 1 highlighted and then fill it down, that makes it more appropriate. So you might actually just want to highlight these row by row because of that. That's up to you. You might notice these little green triangles at the top of this one. That can very often be ignored. It just thinks that because there's so many numbers over here, maybe I meant to use something else. That's what it's saying. Hey, did you mean to do something else? But I know I didn't. So we're adding the same amount every single year, just that Starbucks cup of coffee. And we are completely ignoring inflation. That cup of coffee, same price 10 years later. So our pre-interest balance goes up every year. Our interest, remember, is based on before we added the most recent years. So year 3, this 240 is year 3 starting balance times the 9%, which is now 240 bucks. Now I got $4,000. Year 4, now we got $6,000. Year 5, now we got 7,600. This interest is growing pretty rapidly. By year 8, we're gaining $1,000, whereas year 2, we were gaining $100. Now we got $20,000 10 years later from Starbucks alone. Now we said Bob starts at 18 and he's going until he is 68. So 50 full years of his life giving up Starbucks. So let's take this all the way down to year 50, which means I need row 51. So Bob will be 68 then. I'll highlight. Now remember, as you do this individually, you're going to get a lot of blanks. Let me scroll out some just to make this quicker. Let's drag down the adding of a Starbucks cup of coffee every day number, the 1277.50. Let's drag down, and these 3 I can do all at once. Drum roll. What do you think? $10,000? $100,000? Holy cow. $1 million. $1 million. I told you at the beginning of this semester that I could make you, in theory, a millionaire off of a Starbucks cup of coffee a day. As long as you retire properly, you start at 18, you go ahead and start shoveling money away. Oh, but Mr. Beckner, I can't do this. I've got all these other loans. Okay, if you've got high interest loans, maybe pause on this. As long as your loans are over 7, 8, 9%, you should chip away at those first. Again, opinion. Trust me, the math is there to prove it. But I wouldn't even, if you have a mortgage, that's not something you need to take care of before you start retiring. If you've got college loans, depending on your college loans, maybe you can go ahead and do this, maybe not. But let's say if you didn't start at 18, maybe you started a little bit later, what would that effect be? Actually, fairly drastic if you wait 10 years. So there's a couple things about this problem that make it even more likely that Bob can be a millionaire. When Bob's 18, Bob's probably making a couple grand a year if he's in college. When Bob's 68, Bob's making a lot more than he did in college. Bob can probably sacrifice a little bit more of his paycheck. So maybe he increases this by, say, 2% every year. So you could actually go back into these formulas and increase your payment. So let's say, instead of just doing a flat 12,750, let's go equals the previous year's times 1.02. That's a growth factor. That's saying an extra 2% on top of the 100%. So then year 2, now he deposits a little more. And you might even say that's just because of inflation. And let's see if I do this, if it'll fill in properly. Yes, it does. So now, going up 2% every year, that means now he's putting in about 3 grand in his 50th year, which is still a small amount of money. And Bob now has $1.3 million. 3 grand at age 68 with a good salary and a house paid off is nothing. In theory, maybe you've got crazy medical bills, maybe you have 12 kids, maybe you're taking care of 7 families, I don't know, but the idea is that this should be a minuscule amount of money. When you have a 401k contribution, that generally ends up being in the $1,000, $2,000, $3,000 range for someone making, say, 50 grand a year. You can do IRAs on top of that outside of your employment, and you can deposit up to $6,000 a year. We're not even hitting that threshold with this 3,000, and that 6,000 threshold is going to be way higher 50 years from now. If you are 18, you need to take this serious. If you are 28, you need to realize that maybe you've missed 10 years of this. So what's the effect? What is the effect of having missed 10 years? And I'm trying to remember if I have that typed out here or not. I believe I do. I do. Actually, let's hold off on that. Let's do the free money part and the scatter chart before we get there. Sorry. Okay, so let's go back to when we had the same deposit and we got our $1 million. So scatter chart. So the years. Why do I have the year column twice? What happened? Did I have that the whole time? I'm losing my mind. Maybe I did. I feel like something happened though. Yeah, losing my mind. All right, so I'm going to highlight all 50 years. I'm going to scroll back up. What is happening? Highlight all 50 years. Scroll back up. Control. Ending balance. Let go of mouse, let go of control. Insert. Scatter chart. Look at that explosion of money. That is the steepest one we've seen because we didn't just put money away one time. We continued adding to the pile as much as we could, like a good retirement plan should be. Pensions don't really exist anymore. And quite honestly, I mean, they were good 30, 40 years ago. When they were being phased out in the 2000s, they started becoming trash. And I may or may not have a pension that may or may not be trash. Notice that I'm speaking in may or may nots, but you may be able to make a assumption of what I'm trying to say there. So people that started their careers that have quote pensions in the mid 2000s, most of them still need to be adding to this pile of money because a pension is a linear growth. No matter what, it grows linearly once you start pulling your money from it. But a retirement account with IRAs, 401ks, mutual funds, etc., these things continue to grow exponentially. Okay, so big explosion, big explosion. We're now millionaires. You might say, well, Mr. Beckner, I'm just going to do the S&P. What if this was a 7% growth instead? Let's change the 9% to a 7%. And look at that. We still have $520,000. Well, okay, so just increase your deposits every year a little bit, and you're probably going to hit your $1 million. But still, nobody's going to cry for having $500,000 for depositing a Starbucks cup of coffee. But let's go back to the slightly more aggressive, especially when you have 50 years, you get to be super aggressive. If you lost all of your money year 10, it basically wouldn't even matter. I have a wrong number in here now. What is going on with this? Please be right. Those look like the numbers before. Okay. So we have our ending balance. We wanted to find out how much was free money, which is interest. Well, interest is the difference of what you put in and what you have. It's the ending minus all deposits. Well, the ending amount was at 1,041,269.24. So we'll go equals that cell. And then we're going to subtract all the deposits. What did we deposit? We deposited 12,7750 each time. So 1277.5. I could use a cell reference if I wanted to. And we did it 50 times, so times 50. You could go ahead and multiply that ahead of time. G510 minus 127750. That makes 51. There's a 0 in there for some reason. There we go. That's the cell minus the 127750. There we go. This is our interest. Once again, that was the cell that had the ending balance, that $1 million, that's what G51 is, and some change, minus the deposit we made, which we made 50 times. And again, that is $977,000. How much did we actually deposit? We deposited that 1277.5 times 50. We put $64,000 of our money in. That's it. We put in $64,000 and we became millionaires. Think about that. Think about that and understand, once again, the importance of doing a proper retirement over a long period of time. You get so much money for free if you start young. And that's because of compounding. It's because of this snowball effect. If you do this in a CD, if you switch this to 2%, these numbers are going to be drastically reduced. Let's see. All right, I'm going to put my money in just CDs every year, 2%. What's our ending balance? $100,000. You're not retiring on $100,000. We've still deposited $64,000. We ended up with $100,000. So we basically got 40 grand for free. That is chump change in comparison to being a little aggressive, especially in the beginning, especially the first 10, 20, 30, 40 years maybe. You can start pulling back and doing a lot more bonds that last 10 years. And that gets you almost $1 million for free. And if you did all this in a Roth IRA, every single penny of that $977,000, tax-free. You'd pay taxes on the 64 grand and you'd have tax-free $977,000. Tax-free. Because if you had to pay taxes on that, you'd probably lose a quarter of it, maybe 20% of it. Now, you're not going to be sad having $800,000, but you're going to be happier having $977,000 for free. Okay, so now going back to the question, Bob waits. What if Bob waits 10 years to start? How much does he have to retire on? What if he waits 20 years? So by waiting 10 years, that starts him at 28, going to 68, that's only 40 years. If he waits 20 years, he only gets 30 years to add to this pile. So again, note, if you do not have to do, I said if in there, there's no if. You do not have to do any new math to figure this out. Excel already has the answer. You're just cutting 10 and 20 years off of what you already have. So instead of going to year 50, go to year 40 for that first question. Go to year 30 for the second question. So year 40, this is if Bob waits 10 years. So if Bob waits 10 years to start his Starbucks deposit every day, Bob is only going to have $430,000. Do you see how drastic that is? Starting at 18 makes you a millionaire. Starting at 28, you only have $431,000. Again, just $431,644. I'm killing the cents. I don't care about the cents. Yeah, that's awesome. You got $400,000 and some change, especially if it's tax-free in a Roth IRA. But knowing that if you'd started 10 years earlier, you'd have more than double that, ooh, that fact hurts a little. Maybe some of us already feel the effect of that fact. Maybe your teacher's raising his hand, because maybe your teacher may have had a pension and thought, hey, pension's fine. Point is, even the best of us learn this sometimes later in life than they should have, because they don't teach this stuff in high school, and they should. And they don't teach this stuff in the news, and they should. And you don't see this stuff just on random websites that most people visit, but it should be there. This is one of the most critical components of your life, unless you want to work to the grave. All right, so waiting 10 years, $430,000. Good, not great. All right, what if you waited 20 years? That means you only get 30 years of this Starbucks growth, $174,000, 174,132. Can I put that up there? Waiting 20 years, you get just $174,000, 132 and some change. That's not enough to retire on. Unless you're only going to live another 3 or 4 or 5 years. So now the question becomes, how would you fix this to still be a millionaire? Assuming you still do this aggressive 9% growth. Again, this 9% is a big assumption. 7% is a safer number. But I think anybody who's willing to learn a little bit about how stock markets work, how mutual funds work, you can get that extra 2%. I believe. Again, I'm not guaranteeing, I believe. So how do you fix this? You need to deposit more money. So instead of depositing $12,750 every month, maybe we need to double that. So if we double $12,775, you'll get $2,555, a number you may have seen at the beginning of this when I had it before I erased everything. So let's now deposit $2,550 every month. Let's just see what happens. So now this is me try doubling the deposit. So now instead of depositing 1 cup of Starbucks every day, we're depositing 2 cups of Starbucks, maybe a Starbucks coffee and that cruller we were going to get, or a full Chick-fil-A meal, whatever it is. So now let's take that number and drag it down to, so we cut 10 years. Let's just look at the 10-year scenario. So I'll erase everything from here on out. So this is the 10-year scenario. If you double your deposit, it's still not enough to make you a millionaire. So by waiting 10 years, you need to more than double your initial deposit to become a millionaire. All right, so let's just spitball some numbers. Maybe 3,000 to work. If I put 3,000 in every day. 1.013, that's close enough. So we need about $3,000. We went from 1,700 to 3,000. So 3,000, let's see how much we had to increase that by. Divided by, was it 1777.5? No, 12.7. The number's staring me in the face. So proportionally, we are depositing 2.3 times as much money every single year, or every single month, or every single day, however frequently it is we're making these deposits. You need to deposit about 2.35 times as much each deposit with 10 years cut off. So if you start at 28, now you need 2.35 Starbucks coffees deposited every day to get that $1 million with aggressive growth. What about for the 20-year cutoff? So now let's cut off years 31 through 40, which puts us at that $410,000 with 3,000. I think that makes sense since we're kind of comparing to the previous numbers. Let's double this to 6,000. Let's see what happens. Now you might be able to figure out that I might be doing 2.3 times it, 2.35, whatever. Still not a millionaire. So if you took 3 grand times 2.35, that's 7,050. So let's try that, 7050. So that's our annual deposit. And it almost gets us our $1 million. So it's a little bit more actually. So maybe 7,100. Almost, maybe 7,300. This is just me trying things out. Almost there, 7,400. Boom, we hit our $1 million. So we need $7,400 every single year. So 7,400 in comparison, 7,400, I don't like this digital calculator, divided by the original 1277.5, that is 5.8 times as much every time. Basically, every 10 years you wait, you need to deposit 2.5 times as much money to hit that $1 million, or whatever your goal is. It doesn't have to be $1 million. If your goal is $500,000, if you wait 10 years, your deposits, you need to roughly multiply by 2.5 to hit that same goal. Again, what's the point of this? Start young. So 5.8 Starbucks cups of coffee. So 5.8 times 3.5, that's now $20 a day. That's a lot more significant. Is it still possible? Sure. I mean, maybe you're 20 years in, maybe you're 38, and now you're comfortable. You got your student loans paid off, your car loans paid off, your credit card bills are gone. Now you're ready to start hitting this retirement hard. And maybe you can put 7 grand away every single year. Well, if you were talking right now, you would only get 6,000 of that tax-free if it's going into an IRA. Maybe the other 14 is going into a 401k. Maybe not. I don't know. I can't tell you what you're doing, but you could still probably get all that tax-free in today's economy, assuming you have access to the IRA and a 401k. But that is where we're going to end today. And again, the takeaway here, this is the biggest takeaway in the whole course, in my opinion, because this will have the biggest effect on your lives, your financial lives, whether you're working till the grave, or maybe you have some years where you're spending a week or two on an island and traveling the country, or just relaxing, or paying your medical bills comfortably without losing the note on your home, or adding another note on your home, meaning another mortgage. So with that being said, I hope that you took something away from this. I hope that you are able to recreate these. This is something I would love for you to be able to recreate. You know what? I had a quiz question ready, but it's 10:45, so we'll skip the quiz today. Again, make sure you have all those due dates. If you came in late, here they are. So we have finished 6.1, so that's due on the 27th. We'll be covering 6.2 next class, so that'll be due on the 29th. We'll have another Excel homework after the population. I'm going to start grading your Excel homeworks, your Excel projects around 1 o'clock today. I'll get as many as I can done. Hopefully all those grades will be done today. If not, worst case, they'll be up in Canvas by 3 p.m. tomorrow. So have a good one. I'll have this posted in Canvas in a short bit. And we'll see you on the internet Wednesday. Take it easy.